So our topic is here critical assessment of sandstone erosion with the aid of pulsating water jet. And this is our research topic along with my research scholar. Mainly it is done by my research scholar Rupam Tripathi. She has already been awarded the degree. And we have conducted those experiments in a place called Ostrava, the third largest city of Czech Republic, and with a high pressure water jet and pulsating strategy associated with that. So what is rock erosion? The importance of rock erosion is that natural stones are widely used as a construction material, age old, maybe in Egyptian civilization where pyramids are built, then Mesopotamian civilization, then Indus civilization, everywhere people are using those rock. Even our Taj Mahal also is made of the marble rock and all those things. So it is used as a construction material in several industries for both internal as well as the external use. And demand for the natural stone ages has never been increased every time. Even today's building, we are using those kind of things. So due to their unique properties as excellent resistance to environmental influences and attractive decorations, so people are using the granites and other kind of materials in order to do those kind of buildings. And to remove the material of such a brittle material like, say, rock, it is always a challenging one. And there is a prospect of water jet technologies, how nature is doing. The only difference is that we have to do it in a faster mode. So that is by water jet technology, maybe high pressure water jet technology. So evolution of those water jets and maybe specifically with some applications of pulsating water jets, this will be done associated with those removal of materials. So one possible methods to achieve is by erosion phenomena by pulsating water jet. The advantage of water jet is that any material we can cut, any. In laser, there is a restriction so far as transparent material cannot be cut, reflective material cannot be cut. For EDM, where EDM, we cannot cut insulating material, non-conducting material. So everywhere there is a problem. But water jet has no problem if we can have the high value of those pressure. So there are different classification. One is water jet with abrasives. Abrasives will act as a micro tool and water jet will be the delivery mechanism of all those things. So that is abrasive water jet. Another one is continuous water, pure water jet, no pulsation, straightway, high pressure, maybe say 200 megapascal, 300 megapascal used in order to cut across very, very difficult stubborn material also without having heat affected zone. The third one is a clever one, pulsating water jet with lower pressure than the continuous water jet. If the pulsation is inflicted into the water jet, we can disintegrate the material like even these sandstone can be easily disintegrated by pulsating water jet at lower pressure. Well, the disintegration is our objective. So there are some limitations with abrasive water jet. The problem is that we have to mix those abrasive and appropriate mixtures, which has to be there, handling of those abrasive, recycling of those abrasive. Those are the things are there. It cannot be worked as a low pressure also. And pulsating water jet tending towards erosion of material at lower pressures because the pulsation will have a hammer effect and that will develop a fatigue stress, cyclic stress, and that is responsible for the micro and then macro failure and disintegration of the materials like, say, sandstone. So this is a terrific technology in order to get that even at lower pressure than the conventional water jet. I have discussing about the importance of the rock erosion. The pulsating water jet is a very recent developed technology where pulsations are inflicted and on the basis of that the material erosion takes place. So this is conventional rock cutting has many limitations because if we are doing mechanical work, We have a lot of problems of the wear and tear and all those things. And blasting problem, we are seeing all those things in Hiroshima. There are a lot of cracks propagating because of the blasting and very difficult to attack. Mechanical cutting, blasting, all are problems. Impact hammers also sometimes very cumbersome. So one technology may stop. What it is and it is less problematic otherwise. So far as the environment is concerned. So here we will discuss about the importance of rock erosion, conventional process, pulse erosions, mechanism of erosions, some literature survey, the gap, the gain, and on the basis of that, it will be our research and put into that. One can see. So this is the pulsation water jet. One is the advantage of the pulsation is that mechanical devices and all those things, full lifetime of the moving components. So disadvantages, low depth of modulation of the liquid jets, high varying vibrating components. Again, you can see this pulsation and then the how it is implemented. It is implemented by the piezoelectric transducers. The beauty of the piezoelectric transducers is that whenever the voltage changes, it will change the dimension, and on the basis of that, it can give some pulsation in the pressurized liquid chamber. And this liquid supply all providing to that, and that will be resulted in the pulsations of the water jet, and that will deliver the results at high pressure, moderately lower pressure than the higher pressure for the continuous water jet, and it will give the results. So in the first stage, this is the mechanism. The first is the target material, and then it is having the water hammer pressure, hammering effect. In the second stage, it will just spread it out, and that way it is two stages of the liquid will be impact the solid interfaces. On the basis of that, so the previous work done on rock erosion is that abrasive water jet with granite, these are the parameters. So for instance, nozzle setups, depth, width, and volume, all those things are there. Then continuous water jet related to sandstone. Some people have done abrasive water jet on granite. Some people have done water jet on sandstone. Some people have done abrasive water jet on granite, shales, and other part of it concrete. And these are the parameters, whatever the process parameters related to that, and surface hardness and fatigue strength they have calculated. And some people have worked on the pulsating water jet on concrete, and these are the different settings related to that. Then some people have worked on the continuous water jet on granite and marble with these kind of specifications. Water jet people have done on sandstone, and pulsating water jet people have started doing on granite and marble. And people have also done all those metallic parts in copper alloy, bone cement, stainless steel, and the carbon nanotube and concrete composites, and different yield parameters are monitored. So pulsating water jet have the three divisions, water jet, and one is the continuous water jet. That is evolution period is 1970 to 1986. The reason is that otherwise the high pressure water generation technology was not discovered. This is the period where with some intensified people have come out with higher pressures. Then people have thought of that mixing of those abrasive in order to make it more yield and depth and other things are easier. And then the latest development maybe at 2012, people have come out of those pulsating water jet advantage is that the pressure we can work, we don't need some kind of abrasives, and there is integration of the different materials like granite, marbles, and things can be carried out. The pulsation parameters. So the summary is that conventional blasting and hammering and non-conventional abrasive water jet are used to erode rocks at various, but these variation and sometimes that there are some operational hazards. So advantage of PWJ, that is pulsating water jet, is that solution for the problem has employed variety of applications at lower pressure, because whenever the pressure is very, very high, like continuous water jet, enormous problems are coming out of implementation, all those things, high pressure water jet with high burst pressure, and all those wear and tear of all those things, energy consumptions, handling of those pressures becomes very, very difficult. And whenever we have the only objective of erosion, definitely pulsating water jet gives a better result at lower pressure comparison to the continuous water jet. And it doesn't have, just like abrasive water jet, the problem of mixing all those abrasives. So the research gap is that increasing demand for the underground facilities, transportations of metropolitan, and where we have to disintegrate all those rock, have to be rapidly expanding all sorts of metro rail projects, maybe some bullet train projects in the tunnels and other part, and we cannot just have those blasting, drilling and blasting, and the conventional mechanical erosion strategy of those machines. So water jet technology reduces the unconventional excavation, and pulsating water jet can give very good clean repairing at lower pressure in comparison to that, and that is the biggest advantage of those pulsating water jet, and that is why we have to do research on that. So aim of this research is to see where different kind of groups created by pulsating water jet, and to find it out the performance analysis of those pulsating water jet and continuous, and what is the difference of it, CWJ and PWJ, optimization of the major process control parameters to get the best possible yield, that is erosion. The optimization of process parameters are jet pressure, standoff distance, traverse speed, along with the pulsation frequencies in case of pulsating water jet. And the materials is mainly the rock one, granite materials, because brittle material can also be disintegrated very easily by these material, by these pulsating water jet, which is very, very difficult in order to do. So this is pulsations and wave patterns, and pulsations are termed in terms of waves, and different megapascal we can give with different frequencies. We have been able to publish our paper in top 3 world journals in rock mechanics and mining sciences. One category in wave of science, effect of this pulsation frequencies and pulsation pressure on physical. High speed camera of the pulsation is causing the hammer effect.
Sir, for this particular slide, the audio was not audible enough.
Acha,
For
okay,
this,
now
yes,
you
sir.
can.
Now, yes, now
Okay, I think the mic was slightly away
yeah,
from mine, so
yes,
I will keep it in that.
yes, sir. Thank you,
So
sir.
here, this is the display of the pulsation, and this is the continuous one, and we have these at lower pressure also. With the pulsation we can get better erosion results. Maybe the problem little bit with associated with the surface finish and accuracies. And this is the experimental apparatus associated with the Asian brown Bovary robot along with the manipulators of the pulsation, and this is the vice and the sandstone, and all those things are kept for this cutting activity. So the main properties, whatever of all those materials, are the specific gravity of those rock we have done, bulk density, water absorptions, capability, and all sorts of things we have found it out, because we have to meticulously find it out of all those parameters. On the basis of that, we have to fix up our strategies of disintegration. And this is the different frequencies. Only problem is that it is such a complex and complicated device that we cannot play with the frequencies just like that. We can only do that for 20 kilohertz and 40 kilohertz. Apart from that, every time big setup things are there, and may not be possible always technically to do so many. Though the reviewers have commented that why other frequencies are not tested, it is technologically very challenging and becomes very, very expensive in order to change that. So we have carried only, the limitation is that only two frequencies we have carried out with those pressures 20 and 40, and the nozzle diameter has a role, standard distance also has a very big role to play, and traverse speed. So these are the nozzle parameters, these nozzle dimensions, standard distance and traverse speed. And definitely pressure is the main driving force, and the frequency. 1, 2, 3, 4, and 5. These 5 combinations with some design of experience we have carried forward, but only the pressure levels we have taken 2 and frequency level 2, and other things out of pilot experiments we have fixed up. So these after cutting, we have to do a very high-end optical topography of all those grooves and other things, and maybe throughout the night, these machines of the topographic grooves and other things are studied, recorded, digitized, and analyzed. That how the disintegration pattern of the different frequencies and process parameter actually happen. So with the topographic analysis, we are just finding it out at what kind of traverse speeds, what will be the thing associated with that, and critical comparison with the pulsating water jet and continuous water jet. So these grooves generated by continuous water jet, when the particles were removed from the chip, the problem is that CWJ is always require very high pressure, and sometimes it is very challenging in order to implement those kind of things. So 3D images of different CWJ in terms of 40 megapascal, and we can see also compare them along with those with PWJ. So these are some of the behavior patterns. This is a 20 megapascal, this is 40 megapascal, and this is the depth, and this is the traverse speed, and 60 megapascal, and according to that it is plotted with the different graph, and so that know what is the behavior pattern in different kind of speeds, traverse speeds and depth combination, and what kind of combination we can get associated with the different speeds. So multi-dimensional process parameters will give different results. So complex design of experiments has to be carried out. So we can see the repetitive impact of the pulsation pressures leads to local shear propagation. So this is the traverse speed, and whenever traverse speed is increasing, the width is definitely decreasing. That is obviously because whenever you are putting those dwelling, definitely the width will increase, and whenever the dwelling is less, that means the traverse period is more, the width of all those grooves are getting less, and that is true for the different values of those pressures. So 20 megapascal with pulsating water jet, 20 megapascal with continuous water jet, and all sorts of color combinations with CWJ and PWJ are critically compared to find it out that PWJ, even at lower pressure, they are giving very good results comparable to higher pressure one. But only thing is that the question is dimensional accuracies and surface finish may not be that great in case of PWJ. So these are all, we have done extensive experimentation with all those different pressure level along with the pulsations to compare the difference between PWJ and CWJ. So there are some theories. I am not going into much of the detail. So that is a very basic theory, just like ultrasonic material removals. Another part is an hammering effect, and on the basis of that, we can find it out what is the role of the frequency analytically, and on these things we can find it out what can be the preferred diameter of the nozzle and the pressures, so that to manipulate these things in our favor. So comparison of the impact forces, a lot of comparison has to be carried out with pulsating water jet and continuous water jet with the different values, how they are coming in terms of yield, and that is shown. And definitely that has to be supported by some micrography. Some optical microscopes are there in order to find it out, those grooves and their characters and their behavior pattern, and that can be tested very critically with PWJ, pulsating water jet, and continuous water jet to justify that the erosions of all those things take place at lower pressure is equivalent to that, but definitely surface finish accuracy may be a question. You can see this cross-section view of each group treated by the different traverse speed to find it out at different stand-off distance, because stand-off distance has a big role to play in order to determine the material removal rate or erosion rate of materials. You can go for a very bigger one scales with the feldspar grains, the disrupted with the cleavage plane, and how those groups they are behaving, and they have some displacement, they have some slips, they have some tuning, and all sorts of things are taking place, and that way ultimately the material is removed by the fatigue stress. Micro cracks, then major cracks, then fatigue failure, and all sorts of things will happen in those materials. So the conclusion is that depth of the cart, we have to fix up what is the optimization, what will be the depth of the cart in a complete CWJ, and that has to be compared with what kind of process parameters, that is the main objective, in order to get the very specific targeted erosions of all those materials, and to find it out and to justify that it is at lower pressure with pulsation frequencies we can generate, and lowering of the pressure, it is less challenging so far as technology is concerned, and less costly affair, and it is more reliable one. So we can see the erosion effect of the sandstone during different changes of the frequencies. So some frequencies we can find it out that frequency is also doing the hammering effect much better, and on the basis of that we have to control. But definitely that has to be more exhaustive with the different frequencies, but generating on the frequencies and implementing on those high pressure water jet with some robotic manipulator with fixed tire speed. So that is why we have only two away with two classes of frequencies. So one can see all those pulsating water jet coming of that. The nozzle geometry is also sometimes important. So many parameters. It is a computationally combinatorially complex problems. So at least with some pilot study and the feasible domain, we have found it out, but there are infinite possibilities of the combination. And that makes the research is a very complex one. So these are the very parametric condition. On the basis of that, with a lot of experimentation and pilot study, we have come out with, and according to that, we execute. So the main properties of the mineralogical compositions of the sandstone, whatever, the problem is that different places sandstone have different properties. So whatever we have taken, and on the basis of that, we have reported our results, so that the people can do these kind of sandstone, these kind of strategies, and that will be the real takeaway from this research. The variation of the depth of cut is also plotted with different feed rate, with different frequencies, in order to get that what kind of exposure it will give for different kind of erosions. So all those things are for the people in order to apply them. We have done the experimentation for them, so that our data and other things are useful for the community, industrial community, to know that what kind of effect we can do that even with a lower pressure of water, but with some pulsating effects. So these are, I'm not going into much of the details. They have their own significances. They have some little uncertainties also, some initial values, and then their predictable curves and other things are there in terms of those eroded volume. Eroded volume is the most important thing, and on the basis of that, in unit time, it is the erosion rate is determined. So we can see the different topographies of the groups created by those things at different frequencies, and we can analyze all those things, how it is coming associated with those things. And this is the scanning electron microscope analysis of those groups, and how these fatigue failures are taking place in different kind of cracks, how initiation, then micro cracks is converted to meso cracks, and ultimately failures. All those things happen at different kind of frequencies with high pressure water jets, some values, finite values. You can see all those things, crack generation, crack character, and how this is propagated in order to go for erosions of all those little rocks. So comparison with these erosion methods, what kind of erosion methods, the volume method, volume erosions, and those things will be taking place with the different kind of other kind of limestone, Indiana limestone, Baltic. So not many these different sources of limestones are different sources of sandstones are different, and we have to carry out an exhaustive figures so that the people, whenever encountering this kind of stones, what kind of process parameter they can suggest for that ultimate erosion will take place. So there are conclusions. Effect of the frequency was observed, and we are finding it out with the traverse bed because combinatorial explosions are there. Lot many parameters, but main focus is the frequency parameters, how better it can give in comparison to the continuous water jet, and their height and standard distance, how the combinations can give what type of results for very specific type of material. And just to prove that, okay, if we can pulse arrangement for the pulsation of the water jet, definitely at lower pressure, we can ensure the erosions of those materials and brittle materials like sandstones and rock. You can see the different kind of design of experiments with the different levels, 20 and 30, then traverse speed 150 and 175, 200, and the standard distances also changes from 280, 30, 40, 50. And if apart from that, the frequencies are there, so it will be a bigger and bigger number. So any change more than frequency options, then definitely the entire systems are costly and cumbersome. Only we can change after a lot of effort on the two frequencies. So they are all experimental results along with the meticulous observations of all those widths, and sometimes machines also optically can observe these kind of dimensions. That is the advantage of using very, very great machines, to analyze the results. So the input parameters and the output parameters are determined on the basis of that how much volume erosions are coming, and according to that we are finding out what is possible results. And then analysis of variance. Without analysis of variance, we cannot tell that what are the role of influencing parameters, or process parameters, only parameters. So people have to do a lot of standardization ANOVA in order to find it out the responsible parameters related to that. And from the analysis, various parameters are done, and large values significant change in the performances. So there are the advantages of using statistical techniques to tell that which kind of cases, which values will tell for the better erosion rate, and which is needed by the experiment industries. And definitely that was also a very important goal for the research scholar. So that is plotted in some kind of befitting equations, linear equations are fitted with in order to predict all those values and find it out whether they are capable of depicting those things, and that has to be determined with, say, right kind of specific distance. So the different optimization strategy, desirability functions were studied in order to get the optical one, so that without much hassles people can get best possible results and the cost of operation comes down. So some experimental, we have calculated all those errors like R square and adjusted values, and optimization from results in optic parameters to response predicted and measured values. So that is the black box approach. Even from exhaustive data, there definitely we can also think of with some other kind of locations in order to carry forward this kind of experiment. Thank you very much for your patience here.